When dealing with a 100 amp disconnect on a pole feeding a mobile home and the neutral bar lacks sufficient space for both the neutral and ground connections, it is permissible to attach a bolt-on lug to the enclosure for the ground wire, provided certain conditions are met. Firstly, the enclosure must be properly bonded to the neutral bar. This ensures a continuous, low impedance path for fault current. Secondly, the bolt-on lug must be listed for use with the enclosure type. For example, if the enclosure is NEMA 3 R rated, the lug should also be rated for NEMA 3 R environments. Thirdly, the lug must be properly torqued to the manufacturer's specifications. This ensures a secure and reliable connection. Fourthly, the ground wire must be properly sized and terminated. Refer to applicable electrical codes, such as the National Electrical Code, or NEC, for proper sizing. Here is a step-by-step procedure for attaching the lug and connecting the ground wire. Step 1. Prepare the enclosure. Clean the surface of the enclosure where the lug will be mounted to remove any dirt or debris. This ensures a good electrical connection between the lug and the enclosure. Step 2. Attach the lug. Use machine screws to attach the bolt-on lug to the enclosure. Ensure that the screws are properly tightened to the manufacturer's specifications for the lug and the enclosure material. Step 3. Connect the ground wire. Terminate the ground wire to the lug using an appropriate connector, such as a ring terminal. Ensure that the lug is properly torqued to the manufacturer's specifications. This method can be used to provide a bonding jumper between the enclosure and the neutral bar. In some cases, a grounding bushing may be installed in the enclosure to facilitate the ground connection. Always refer to the manufacturer's instructions and applicable electrical codes for proper installation and grounding procedures. The NEC is a comprehensive set of standards that provides guidelines for safe electrical installations. When installing a grounding system, it's essential to adhere to the NEC requirements. Section 250 of the NEC covers grounding and bonding. It specifies the requirements for grounding electrodes, grounding conductors, and bonding jumpers. Grounding electrodes are used to connect the electrical system to the earth. Common types of grounding electrodes include ground rods, ground plates, and metal underground water pipes. The grounding electrode system must be installed in accordance with NEC requirements to ensure a low impedance path to ground. Grounding conductors are used to connect the equipment grounding system to the grounding electrode system. The size of the grounding conductor is determined by the size of the overcurrent protective device in the circuit. Bonding jumpers are used to connect metallic parts of the electrical system together to create a low impedance path for fault current. Bonding jumpers are required for metal conduits, metal enclosures, and other metallic equipment. Proper bonding ensures that all metallic parts of the electrical system are at the same potential, reducing the risk of electric shock. When installing a grounding system, it's important to use listed and labeled equipment. Listed equipment has been tested and certified by a recognized testing laboratory to meet safety standards. Labeled equipment is marked with the manufacturer's name, model number, and other information that identifies the equipment. Using listed and labeled equipment helps to ensure that the grounding system is installed correctly and will function properly. In addition to the NEC, there may be local codes and regulations that apply to grounding systems. It's important to check with the local authorities to determine what codes and regulations are in effect. Following all applicable codes and regulations helps to ensure that the grounding system is installed safely and correctly. When working with electricity, it's important to take safety precautions. Always disconnect power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you're not comfortable working with electricity, hire a qualified electrician to do the work. Working safely helps to prevent electric shock and other electrical hazards. Specific considerations for mobile home grounding include ensuring the mobile home's grounding system is properly connected to the site's grounding electrode system. The NEC provides specific requirements for mobile home grounding, which must be followed to ensure safety. These requirements address the connection of the mobile home's grounding conductor to the site's grounding electrode, as well as bonding of metallic parts within the mobile home. One common method for grounding involves using a ground rod. A ground rod is a metal rod that is driven into the earth to provide a connection to ground. The NEC specifies the size and type of ground rod that must be used, as well as the depth to which it must be driven. Another method for grounding involves using a ground plate. A ground plate is a metal plate that is buried in the earth to provide a connection to ground. The NEC specifies the size and type of ground plate that must be used, as well as the depth to which it must be buried. Metal underground water pipes can also be used as grounding electrodes, but they must meet certain requirements. The water pipe must be in direct contact with the earth for at least 10 feet, and it must not be insulated. In some cases, a supplemental grounding electrode may be required, such as a ground rod or ground plate, to provide additional grounding protection. The size of the grounding conductor is determined by the size of the overcurrent protective device in the circuit. The NEC provides tables that specify the minimum size of the grounding conductor for different circuit sizes. It's important to use the correct size grounding conductor to ensure that it can safely carry fault current. Bonding jumpers are used to connect metallic parts of the electrical system together to create a low impedance path for fault current. Bonding jumpers are required for metal conduits, metal enclosures, and other metallic equipment. Proper bonding ensures that all metallic parts of the electrical system are at the same potential, reducing the risk of electric shock. The NEC specifies the size and type of bonding jumpers that must be used. The size of the bonding jumper is determined by the size of the circuit conductors. When installing a grounding system, it's important to use listed and labeled equipment. Listed equipment has been tested and certified by a recognized testing laboratory to meet safety standards. Labeled equipment is marked with the manufacturer's name, model number, and other information that identifies the equipment. Using listed and labeled equipment helps to ensure that the grounding system is installed correctly and will function properly. Some common grounding mistakes include using the wrong size grounding conductor, failing to bond metallic parts of the electrical system, and not properly installing the grounding electrode system. These mistakes can compromise the safety of the electrical system and increase the risk of electric shock. It's important to avoid these mistakes by following the NEC requirements and using qualified personnel. Regular inspections and maintenance can help to ensure that the grounding system is functioning properly. Inspect the grounding conductors and bonding jumpers for damage or corrosion. Test the grounding electrode system to verify that it is providing a low impedance path to ground. If any problems are found, they should be corrected immediately. Common grounding practices in different regions may vary due to local codes and soil conditions. For example, in areas with high soil resistivity, it may be necessary to use multiple ground rods or ground plates to achieve a low impedance ground connection. It's important to be aware of the local grounding practices and to follow the applicable codes and regulations. Advanced grounding techniques, such as the use of exothermic welding, can provide a more reliable and durable ground connection. Exothermic welding involves using a chemical reaction to create a permanent bond between the grounding conductor and the grounding electrode. This method is often used in critical applications where a reliable ground connection is essential. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electric shock. GFCIs monitor the current flowing in a circuit and will trip the circuit if they detect a ground fault. Ground faults occur when current flows through an unintended path to ground, such as through a person's body. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electric shock. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power grid switching, and other events. SPD divert the surge current to ground, protecting the equipment from damage. SPD are often used to protect sensitive electronic equipment such as computers, televisions, and appliances. Electrical safety audits can help to identify potential electrical hazards in a building or facility. During an electrical safety audit, a qualified electrician will inspect the electrical system to identify any code violations, safety hazards, or maintenance issues. The electrician will then provide a report with recommendations for correcting any problems that are found. Electrical safety audits can help to prevent electrical fires, electric shock, and other electrical hazards. The NEC undergoes regular revisions to keep up with changes in technology and industry practices. The NEC is updated every 3 years, and each new edition includes changes to the grounding requirements. It's important to stay up to date on the latest edition of the NEC to ensure that your grounding system is compliant with the current standards. Electrical codes and standards organizations such as the National Fire Protection Association, or NFPA, and the Institute of Electrical and Electronics Engineers, or IEE, play an important role in developing and maintaining electrical safety standards. These organizations develop codes and standards that are used by electricians, engineers, and other professionals to ensure the safe installation and operation of electrical systems. Understanding electrical theory can help you to better understand grounding principles. Electrical theory covers topics such as voltage, current, resistance, and impedance. By understanding these concepts, you can better understand how grounding systems work and how they protect people and equipment from electrical hazards. Electrical training programs provide comprehensive instruction in electrical theory, grounding principles, and electrical safety. These programs can help you to become a qualified electrician or electrical technician. Electrical training programs are offered by community colleges, technical schools, and apprenticeship programs. Continuing education courses can help you to stay up to date on the latest electrical codes, standards, and technologies. These courses are offered by community colleges, technical schools, and professional organizations. Continuing education is important for electricians and other electrical professionals to maintain their licenses and certifications. When selecting electrical equipment, it's important to consider the environmental conditions in which the equipment will be used. For example, equipment that is used in wet or damp locations must be rated for those conditions. Equipment that is used in hazardous locations must be rated for those locations. Choosing the right equipment for the environment can help to prevent electrical hazards and ensure the safe operation of the equipment. When installing electrical equipment, it's important to follow the manufacturer's instructions. The manufacturer's instructions provide detailed information on how to install the equipment correctly and safely. Following the manufacturer's instructions can help to prevent electrical hazards and ensure the proper operation of the equipment. Regular maintenance of electrical equipment can help to prevent electrical hazards and extend the life of the equipment. Maintenance tasks may include cleaning, lubricating, and inspecting the equipment for damage or wear. Regular maintenance can help to identify potential problems before they become serious hazards. Troubleshooting electrical problems can be challenging, but there are a few basic steps that you can follow to help you identify the problem. Firstly, start by checking the power supply to make sure that the equipment is receiving power. Secondly, check the circuit breakers or fuses to make sure that they have not tripped or blown. Thirdly, look for any obvious signs of damage, such as frayed wires or loose connections. If you are not able to identify the problem, it's best to call a qualified electrician. Electrical safety is everyone's responsibility. By following safe electrical practices, you can help to prevent electrical fires, electric shock, and other electrical hazards. If you see something that looks unsafe, report it to the appropriate authorities. Section 310.15 of the NEC covers ampacity, which is the current carrying capacity of conductors. It provides tables and formulas for determining the ampacity of conductors based on their size, insulation type, and installation conditions. It's important to select conductors with sufficient ampacity to carry the load current without overheating. Section 250.66 of the NEC covers the sizing of grounding electrode conductors. The grounding electrode conductor connects the equipment grounding system to the grounding electrode system. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. Section 250.102 of the NEC covers the sizing of bonding jumpers. Bonding jumpers are used to connect metallic parts of the electrical system together to create a low impedance path for fault current. The size of the bonding jumper is determined by the size of the circuit conductors. Table 250.122 of the NEC provides the minimum size of equipment grounding conductors for grounding raceway and equipment. The size of the equipment grounding conductor is determined by the size of the overcurrent protective device in the circuit. The NEC also includes requirements for grounding specific types of equipment, such as generators, transformers, and motors. These requirements are designed to ensure that the equipment is properly grounded and protected from electrical hazards. When working with electricity, it's important to be aware of the potential hazards and to take precautions to protect yourself from electric shock. Always disconnect power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you're not comfortable working with electricity, hire a qualified electrician to do the work. Electrical codes and standards are constantly evolving to keep up with changes in technology and industry practices. It's important to stay up to date in the latest codes and standards to ensure that your electrical work is safe and compliant.